All right, so in today's lesson, we're going to embark upon learning about how to name compounds with multivalent metals. But before we do that, let's take stock of where we are so far. So when we look at all compounds, I've got a bit of a flow chart here. You know, where we are so far is we've only seen compounds with two elements in them, two different types of atoms, I should say. And so those, what do we call those? We call those binary compounds, right? The bi meaning two. And so, you know, we have two different options here. We can have the case where there's a metal with a non-metal, and we have the case where we have two non-metals. But we're not talking about that yet, so I'm just leaving it out. At this point, we've only talked about compounds with metals and non-metals together. And then, you know, so far we've looked at metals with only one possible charge, and we've learned how to name them. Okay, so for instance, you know, in the case of a monovalent metal, we have, you know, the case where the cation is always going to go first. To get the formula, we're just going to use the crossover rule and then reduce to lowest terms. Okay, and then when we're naming that compound, we're just going to change the ending of the non-metals to "-ide", right? Easy peasy. Okay, what we're going to talk about next, however, are our multivalent metals, right? What do we do? What are the rules that govern how we name compounds that contain those multivalent metals, those metals with more than one possible charge? That is what we're going to do today. Okay, so I want to explain to you a little bit about why it is that we're doing what we do before we get into the rules themselves. Because, you know, for me, I always like to know, well, what's the point of this? Like, why does this rule matter? So, again, just to remind you, and we've talked about this, multivalent means that the metal has more than one possible charge, right? So let's say, for instance, we have something like, I'm going to get right down to it, iron chloride, right? So iron is a transition metal, right? We haven't really talked about trends there, but often a lot of those transition metals have more than one possible charge. They form multiple different cations. And that becomes, well, a problem when naming to the point that we need to have a different rule. Okay, so for example, if I said to you, get me the formula for iron chloride. Okay, well, for me as a chemist, I would be asking you some more questions, and let me explain why. When I look at iron on the periodic table, I can see very clearly that iron is multivalent. Iron forms ions with a +2 charge and a +3 charge. But so how do I know as the reader whether the iron that is in this compound is the iron with a +3 or a +2 charge, right? So in other words, am I talking about FeCl2 or am I talking about FeCl3, right? Which one? So the question again becomes which one? Which one am I talking about, right? Iron with a 2+ charge, as in FeCl2, or iron with a 3+ charge, as in FeCl3. Right, so there needs to be a rule in written form to let the reader know which iron cation we're talking about. So let me get to it. So here's some scaffolding work I want to do just to get you ready for what we're about to learn, so that, you know, it becomes less confusing as we work through it. So I'm going to say that it's going to be really important in these cases to figure out, well, which metal ion is it that we're talking about. And a strategy that I use in class normally is like a reverse crossover method, or like doing a bit of a test cross. So let's take a look. Okay, so if I said to you, identify the charge on the metal in each of the following compounds, then that is like a precursor skill that you need to know how to name a compound with a particular charge. So in Cu2O, I know that copper in this compound is multivalent. So in naming this compound, I would need to know, does this compound contain copper with a +1 charge or a +2 charge? So let's take a look. So if I were to take the copper +1 and cross it with oxygen with a -2 charge, and remember again to have your periodic table handy so you can identify these charges, okay, and I were to just cross those down, then this is the formula that I would get, right? Sorry about that, folks. What I did was I just changed the screen so that you could see this last formula better, right? And so if I go ahead and I do the same exact process, taking the other optional charge for copper, and I cross that with oxygen again, right? That's what I have in this compound. Well, what do I get? I get Cu2O2. Now, this being an ionic compound, I want to reduce this to lowest terms, right? A 2-to-2 ratio is the same as a 1-to-1 ratio. So I end up with CuO. So now I go back and I reference, well, what did I start with? What is the thing that I'm naming? And which one of these two copper ions matches the situation? Well, very clearly, since Cu2O is what I'm looking for to name, and I get Cu2O if I use copper with a +1 charge, in this particular case, the copper ion has a +1 charge. Let's try another example just to make sure that you understand this. All right, so I'm looking on my periodic table and I'm seeing that lead in lead oxide has two possible charges. It has a 2+ charge or a 4+ charge. And so before I even name this, I need to figure out, well, which lead ion is in this particular compound. So I'm going to do that sort of testing out of the two charges again, right? So I'm going to set up, you know, is it lead with a 2+ or is it lead with a 4+? That's what I'm trying to figure out. So if I go ahead and cross my lead 2+ with oxygen, right, then I end up with Pb2O2, which of course is going to reduce to PbO. Whereas if I use lead with a 4+ charge, I have Pb4+ with O2- crossing those over. I have Pb2O4. Right? And now I reduce those to lowest terms, and that's going to give me PbO2. I've just adjusted my screen so you can see this formula a little bit better. So then I go back and say, well, what was the thing that I was supposed to name? Well, it was PbO2. And so PbO2 corresponds to the lead ion having a 4+ charge. Now, so this is a cautionary tale, because I'm guessing that maybe some of you just didn't go through the motions of this and saw this little 2 down there and thought, well, that must be there because the 2+ got crossed down. So just be aware that if the other ion, in this case the anion, has a charge besides 1, then looking at the formula on its own may not be enough. Okay, so in this case, we have our lead ion with the 4+ charge in the compound PbO2. So if that is not clear to you, make sure you reach out and ask for some help, because that is an important concept to make sense of before moving on to naming these compounds. Okay, so we're going to learn 2 naming systems. The first naming system is the stock system. And you might be saying, well, why are there 2 naming systems? Well, that will come up a little bit more in grade 11, but you know, different manufacturers of chemicals still use either one of the different naming systems. And so it's important for scientists to know both of them so that they can kind of maneuver through both of those systems. So the stock system uses Roman numerals in the name to indicate the charge on the metal ion. So we're going to use Roman numerals, but in the name only. So now might be a good time to remind you of Roman numerals in case you forgot that lesson or it never really came up in elementary school. So Roman numerals, you know, if we're talking about a 1 looks like that, or like an I. You know, 2 looks like 2 sticks. 3 looks like 3 sticks. A 4 is not 4 sticks. A 4 looks like this. And a 5 like this. And I'm going to go up to 6. So going up to 6 would be the VI. Okay, so those are the Roman numerals in case that never came up. Okay, so like for instance, when I look at this compound here, I know that right away there's a special rule. I'm going to have to use the naming rules for multivalent metals because tin is multivalent. It has 2 charges. I can't just call that tin chloride. That would be wrong. right? So I'm going to check out to see, you know, is this tin 1 chloride or tin 2 chloride? And so I can see that when I cross the SN2 plus down with Cl minus 1, I end up with SnCl2, which is the thing I'm trying to name. And so therefore, I'm not just going to call this tin chloride. I'm going to call this tin 2 chloride. Okay, and that 2 in Roman numerals, it's what's telling the reader that I'm talking about the tin ion being the 2 plus ion in this case. Okay, so you are going to get the most out of this lesson if you go ahead and you try to name these yourselves, because you will have to do that on the quiz that you have tomorrow. So well worth your while to take the risk and try these questions yourself, and because you will ultimately learn more from that. So what I'm going to do is I'm going to go through them one by one with you. So first of all, I want you to pause the video and try to name this compound right here, FeCl3. And when you're ready, resume the video. Okay. So when I look at this compound, I know that iron can have a 2 plus charge or a 3 plus charge. Okay, so sort of on the side here, I might be saying, okay, well, if I have Fe with the 2 plus charge and Cl that always has a -1 charge in these ionic compounds, then I'll end up with FeCl2, which is not what I'm trying to name, right? That's not what I'm trying to name. So that is a good check to do. Now, so if I go ahead and I say, well, you know, if it's iron, the other possibility for iron is that 3 plus charge, then with Cl minus, I cross those charges down, and that's going to give me FeCl3, which is the thing that I'm trying to name. So that is correct. And that what that tells me is it tells me that my iron is iron with a 3 plus charge. And then I can go ahead and name this compound. It's going to be for sure iron chloride. But if I want to be correct about it, I want to say that it's iron 3 chloride. And no mistaking, if you forget those Roman numerals, your answer will be incorrect. Hopefully you did okay with that. All right, so let's take a look at the second example. And so what I want you to do right now is pause the video and try out this second example. Okay, so let's talk about it. I'm going to go ahead and use yellow on the side here just so we don't have as much confusion. Okay, so copper is multivalent. That is what's telling me that I need to use my Roman numerals. Okay, so I need to figure out, is it copper plus 1 or is it copper plus 2? Now, oxygen always has a -2 charge. So in both cases, I would have the -2 charge. And so the only way that when I cross those charges down, I end up with this little 2 down here. That little 2 is there because of the 2 getting crossed down from oxygen, right? Because if I look at Cu2 plus and O2 minus crossing, that would give me Cu2O2, which I would want to reduce to lowest terms to CuO. And so that's what's telling me copper 2 plus is not in this compound. So in this compound, my copper has a +1 charge. That is the correct charge. And so I would call this copper. One oxide. Okay, so even though it's copper 1, I still need to put that Roman numeral in there, and to leave it out would make my answer incorrect. Okay, one last example to try before we do the opposite, which is to give you a name and ask you to come up with the formula. So PBS. Okay, so I've run out of room on the right-hand side, so I'm going to take up some of my space on the left-hand side here. And so I can see on my periodic table that lead has a 2 plus charge in some compounds, and lead has a 4 plus charge in some compounds. And in this case, I am combining it with sulfur anions, and sulfur anions will have a -2 charge, right? So if I were to cross Pb 2+ with S2-, that is going to give me Pb2S2, which I want to reduce to Pbs. So that's telling me that this lead rather, with a 2+ charge is the lead ion that I find in this compound. And so I'm going to call this compound lead 2 sulfide. And some of you may be saying, well, you know, what happens if I spell sulfide with an F instead of a PH? That is okay. Okay, so what I want to do next is to have you practice a little bit more of this by looking at cases where I give you the name and you're asked to find the formula. All right, so here are 2 examples for you to try. So pause the video, give these 2 examples a try, and then resume when you're ready to take them up. Okay, so at this point, students usually find this actually a little bit easier because, you know, we're in the Roman numerals themselves basically tell you the charge on the metal ion, right? So in this case, this 3 right here is telling me that what I have in my compound is gold with a 3+ charge. And so then I just need to look up oxygen. And when I look up oxygen on the periodic table, I can see in that upper right-hand corner that oxygen has a -2 charge. Also, the trends in the periodic table will also let me know that that charge is -2 for oxygen. And so now I'm just going to use my crossover rule. Crossing over this 3 and this 2 down gives me my formula for gold 3 oxide as AU2O3. And I'm done. And so I just want to look again to see, can 2 and 3 be reduced to lowest terms? No, they can't, which tells me I am done this question. Okay, I'm going to use a different color here for my tin. So again, tin right here, it has a 4+ charge. And so I just need to find the symbol for tin. Tin, it has the symbol SN. And in this case, they're specifying it's tin 4. So I put that plus there. And we're using oxygen again. Oxygen has a charge of -2. And so now I'm just simply left to cross those charges down. So the 4 comes down here, and this 2 comes down here. And what I end up as a result with is SN2O4. But then the 2 and the 4 is a ratio. 2 to 4 can be reduced to 1 to 2. So I want to make sure that I reduce that to SN1O2 or simply SNO2. So now what I want you to do at this point is to stop the video, and I want you to work on the a couple of questions from your worksheet on naming compounds with multivalent metals. I'm going to switch to that screen so you can see exactly what I'm talking about. So on our week plan, you will find under this particular lesson on multivalent metals, you're going to find the list, this worksheet, and I want you to work first right now. The first half of the video talks about the stock system, so you're going to work on question number 1 here, and you're also going to work on question number 3. Okay, the next half of the video will look at classical system, and so we haven't learned those rules yet, so best for you to reinforce the existing concepts related to stock system before moving on. Okay, so the second half of this video is going to ask you to go ahead and listen to the next set of rules talking about the classical system. So the classical system is the Latin system. Sometimes it's referred to as that. But if you have not done the two questions on today's worksheet, first, I'm going to strongly encourage you, before we get into this next new content, to go ahead and reinforce those ideas first. Okay, So classic or Latin system, we have these special endings that tell us whether the metal ion has one charge or the other. So the OUS ending is given to the metal with the lower of the two possible charges for that particular metal, and the IC ending is given to the metal with the higher of the two charges. I'm going to explain a little bit more about that. Okay, so for instance, if I had FeCl2, I know that in this particular compound, I'm going to write a little bit of this out. I have iron with a 2+ charge, and I have in FeCl3, I have iron with a 3+ charge. So what that means for me is that if I'm dealing with iron with the 2+ charge, when I name it, there's an OUS ending that would go there because it's the lower of the two charges. And then the higher of the two charges, which would be iron 3+ for iron, would get the IC or IC ending. Okay, so let's get to the next bit. I'm going to really hope that you have those skeleton notes and that you're filling this in as we go. And so this table is ready to go, ready to be filled in, as with our other notes and other videos. So what I have here is a nice table set up for you where we're going to talk about Latin names, and then ions with higher or lower charges. And so this will be provided for you this year. Normally in a normal non-COVID year, you would have to learn these. But the Latin names for these particular metals, I'm going to give you that on a quiz that comes up. Okay, but you still need to understand it. Okay, so let's get to that. So when I'm talking about iron, the Latin name for iron is ferrum. Okay, and that should make sense because, you know, what's the chemical symbol for iron? Well, it's Fe, right? And so, you know, that should make sense. And so if I'm talking about the lower of the two charges that are possible for iron, well, that's going to be the 2+ charge. Okay, so Fe2+. And then the higher of the two charges is going to be that Fe with a 3+ charge. So remember, the ion with the lower of the two charges is going to get what kind of ending? Well, the OUS ending. And so all I'm going to do is I'm going to take that UM and I'm going to change that to OUS. Okay, so ferrous. Okay, now what ending did we say we were going to give to the higher of the two charges? We said it was going to get that IC ending, right? And so this becomes ferric. And so the same is true as we go down the line for all of these other metal ions. So lead has the symbol Pb, and the reason it's Pb, which doesn't seem kind of to make sense, is because the Latin name for lead is plumbum. Okay? And so when we look at lead on the periodic table, we can see that lead has a 2+ charge and a 4+ charge. Again, you should have your periodic table handy so you can, don't trust me on that, you should see it. Okay, but so what would I call these, right? Take a good guess. What would I call each of these metal ions? So I'm hoping you got to plumbus for the lower of the two charges and plumbic for the higher of those two charges for lead. Okay, and so the same pattern kind of happens when we're talking about the other Latin names and the endings. And so here they are. Copper is cuprum, which means, you know, that I have two different charges. The lower of the two charges is going to be cuprous. The higher of the two charges, cupric. Okay, gold, you'll know, has the symbol Au, and the reason for that is because gold's Latin name is aurum. Okay, so gold has a +1 charge, and it also has a +3 charge. And so I have aurous and then auric as a result. Okay, lastly, tin. I said I was going to be talking about tin and why its symbol was Sn, right? Well, that's because its Latin name is stannum. And so if its Latin name is stannum, you know, then it's going to have two different names. It's going to have a stannous name and a stannic name, depending on whether we're talking about tin with a 2+ charge or tin with a 4+ charge. So there we have it. Okay, and that is essentially the rule that we apply when naming compounds using this Latin or classical system. But essentially that we're just going to go with that and do some practice. So I'm just going to take a minute to move to our Jamboard. Okay, and so what I'd like you to do is I'd like you to pause the video, and in this case what I'd like you to do is to try just this first question, and then we're going to take it up together. Okay, so if you weren't sure what to do and you waited for me to go through it, no worries. I'm hoping that you're trying these questions out just so you can get the most out of the learning piece of this. So when I look at this compound, I know iron has two possible charges. So on the side here, I'm saying, okay, well, I have Fe and I have Cl, and Cl is a -1 charge. So that probably means that this 3 that's down here is there because the iron in this compound has a 3+ charge, right? And so I look on the periodic table and I see that there are two possible charges for iron, iron 2+ and iron 3+. And so since the compound contains iron with a 3+ charge, that's the higher of the two charges. And so remember, the higher of the two charges is going to get that ic ending. And so in this particular compound, I have ferric chloride. Okay, ferric chloride. Okay, let's start the next section. So, or the next question. So give this next example a try and then see how you do, and we'll take it up in a minute. All right, so I look on my periodic table and I can see that copper has two possible charges, copper 1 and copper 2. And so in each case it's with oxygen with a 2-. So if I do my little test cross and I cross those two charges down, I can see that, you know, in this case right here, I'm going to get the correct formula, that's Cu2O. So what that's telling me in this formula, I have copper with the lower of its two possible charges. And you'll remember that that means that I'm going to give the Latin name the OUS ending. Okay, and so this compound would be called cuprous oxide. And that's it. Okay, one last example. Pause and give it a go. I'm going to get rid of a bunch of this, and then we'll get going with that last example. Okay, so final example here. I have lead, and lead in this case, by going through my crossover rule, I can see that I have lead with a 4+ charge, right? So remember, I need to cross those over, and that's going to give me Pb2O4, which I want to reduce to PbO2, to lowest terms, because it's ionic. And so in this case, I have lead with the higher of the two charges, because lead can have a 4+ charge or a 2+ charge. Okay, so because in this compound I have lead with a 4+ charge, that means the compound's going to get an ic ending. So this would be plum. Oops, let me just get rid of that. Plum bic oxide. And I'm done. Okay, 3 more examples, just doing the reverse of that, which is to go ahead and give me the formula given the name. So what I want you to do is I want you to pause the video and give each of these a try, and then come back when you're ready for us to take them up. All right, so let's take these up. So Au means I'm talking about gold. Gold can have a +1 charge, and gold can have a +3 charge. Now that OUS ending over here that I'm seeing is telling me that I have my gold with the lower of the two charges. So I'm going to go ahead and do my crossover rule with that. So I have Au, the +1 charge, and sulfur with a -2 charge. And when I cross down those charges, Same as always, the 1 and the 2 get crossed over, and I end up with AU2S. There we go. Okay, so hopefully you did okay with that. Let's take a look at the next example. I'm going to use a different color here. I'm noticing that it's stanic, which means tin. So tin has 2 possible charges, the +2 and the +4. And that ick ending is telling me that I have tin with the 4+ charge, the higher of the 2 charges. So I have SN with a 4+. Oops, let me just get that done a little bit more nicely. 4+. And I have oxygen with a 2- charge. And I go ahead and I cross those down, 4 and 2. And that's going to give me SN2O4, which of course I want to reduce to lowest terms, or SNO2. And I'm done. So that's the end of our video on multivalent metals and the 2 naming systems. Please reach out sooner rather than later. You should now be able to finish up the entire worksheet on multivalent metals. In addition, what you'll notice on the week plan is a cumulative review that will mix up all the compounds with monovalent metals and multivalent metals all together, similar to what you'll see on your quiz. So make sure you give that a try and consolidate all of these ideas.